And so the backstory is that I have a long-standing interest in the field of glycoscience.
Yeah.
And glycoscience, for the listeners, is the science of complex carbohydrates. And it's a multifaceted science. And when people out in the public hear the term carbohydrate, they often think about food, right?
Yeah.
Food that you eat.
Potatoes.
Exactly, right, exactly. But it turns out there's a whole other universe of glycoscience beyond just food. It turns out that these complex carbohydrates contribute to all kinds of important biological processes in our bodies. And when things go wrong in our body, so when we develop a disease like cancer, for example, or a chronic inflammation of an organ, neurodegeneration, okay, when something goes wrong, sometimes you can see evidence of that disease in the structures of these complex carbohydrates. And those complex carbohydrates can be harvested from body fluids, including blood samples, for example. And so throughout my career, I've been interested in how do you extract the information from glycoscience to help diagnose disease. And it's a simple thing to say, but in practice, it was a very complicated scientific problem. So my lab had been working on this for many years. And all of a sudden, back in the year, I'm going to say 2016, something like that,
Right? Yeah.
I had some outreach from Aldo Carrascoso,
Yes.
who was an entrepreneur here in the Bay Area with success in the tech sector from several companies that he had founded and with big exits. And he was sort of a well-known name in tech. And he had aspirations of contributing to the life sciences, and particularly for the diagnosis of cancer. And he had personal reasons based on family members who had been cancer patients. So somehow he found me, and we ended up having a 3-hour conversation. And he asked the question, why can't people leverage glycoscience to diagnose cancer? Why doesn't that exist already? Why isn't that happening? And it turns out there were 2 reasons. One was the technology was complicated, and the other was it was a big computational problem.
Right.
And
it's a lot of data, as you said, a lot of complexity.
Complex data beyond the capability of the typical life scientist,
Right.
but within the capability of a very sophisticated data scientist.
Rather simple, actually, relative to a data scientist.
Probably so, compared to the other problems that data scientists can tackle, such as modeling the climate of the planet Earth and things like
Astronomy.
that. Right, exactly. But at that point, in 2016, the world of healthcare and the world of data science hadn't quite intermingled fully, right?
We're on the cusp of the biotech convergence, which is our entire thesis at Genoa.
Exactly. Yeah. And I certainly was quite ignorant of what the leading edge of machine learning and artificial intelligence could create. And Aldo was in the learning phase about the process of cancer and glycoscience. So we discovered that the solution to our problem might come from someone with his background and vice versa. So we hashed the plan to form a company to be able to basically do a blood test and characterize the carbohydrates and look for signatures that could tell us whether a person had a disease.